Welcome. In this particular video, we'll be analyzing function notation, absolute value, part 4. Let's take a look at our first example. Example 1. Given f of x is equal to 4 times the absolute value of x minus 5 minus 1, find f of 2. So notice that your input is x in this particular case, and your output happens to be 4 times the absolute value of x minus 5 minus 1. Now, we're interested in finding out what's the value for f of 2. Now, we're going to find out that value by using two methods. So, method number 1, it's based on the description. And what are we trying to describe? Well, we're describing how to generate the function f of x. So, the first step is to pick a number. That's your input, so let's call that number x. Now, notice that to that x, you're subtracting 5. So, that's our second step. Subtract 5. And that's how we generate the expression x minus 5. The next thing we're going to do is to take the absolute value of that. So take absolute value. And by doing so, we get the absolute value of x minus 5. Now notice that the next thing you're doing is to multiply that by 4. And by doing that, what we're getting is 4 times the absolute value of x minus 5. And the last thing we're going to do is to subtract 1. So step 5, subtract 1. And that will generate you 4 times absolute value of x minus 5 minus 1. Now, in this particular case, our input happens to be 2. So we're going to write 2 as the number we select. We're going to subtract 5, so we have 2 minus 5 is equal to negative 3. We're going to take its absolute value, so we have absolute value of negative 3 is equal to 3. Then we're going to multiply that by 4, so we have 4 times 3 gives you 12. And then we're going to subtract 1, so we have 12 minus 1 equals 11. Therefore, we can say that f of 2 is equal to 11. Now let's double check our work by using the substitution method, or method number 2. Now for the substitution method, what we're going to do is to substitute in the value of x equals 2 for any x on the original function. So we copy down the original function, which is f of x is equal to 4 times absolute value of x minus 5 minus 1. And since we're interested in f of 2, what we're going to do is let's replace every single x with a 2. So we have f of 2 is equal to 4 times absolute value of 2 minus 5 and then minus 1. Now here we're going to follow the order of operations and recall that the absolute value, it's a grouping symbol. It's like a parenthesis. So we need to evaluate what's inside first. So we have f of 2 is equal to 4 times the absolute value of 2 minus 5, which is absolute value of minus 3, minus 1. And once again, we need to evaluate what's inside of the absolute value. So we have f of 2 is equal to 4 times 3, because the absolute value of negative 3 is 3, minus 1. And that gives you 4 times 3 is 12, minus 1, which is 11. Therefore, we can say that, once again, f of 2 is equal to 11. Now, this allows us to come up with the point. So we are given the point with coordinates 2, 11. Okay? So we have the coordinates are 2, 11. And how do we know that? Well, we know that because your input, or x value, happens to be 2, and your output, or y value, happens to be 11. Let's see one more example here. Example 2. Given g of x is equal to the opposite of absolute value of x minus 1 plus 7, find g of negative 3. Once again, notice that your input is x, and that your output in this case is the opposite of the absolute value of x minus 1 plus 7. Now, we're interested in finding out what is the value for g of negative 3. So let's use both of the methods previously described. We have method number 1, the description method. So what we're going to do is to describe what we have. Well, the first thing we're going to have to do is to pick a number. Let's call that number x. Notice that the next thing we're going to do to x is to subtract 1. So subtract 1. Therefore, we generate the expression x minus 1. The third step is to take its absolute value. So we have that by taking the absolute value, we generate absolute value of x minus 1. Then we're going to take its opposite. So take its opposite. Now remember that a synonym for opposite is additive inverse, because the opposite and the number itself, once added together, will get you the 0. Or that's why we call them the additive inverses. Once you take out its opposite, let's add 7 here. Now, let's go through this sequence of steps by using the number -3. So we start off with the number. Well, that's -3. Let's subtract 1. So we have -3 minus 1 gives us -4. Then we take its absolute value. So we have absolute value of -4 is equal to 4. Now we get the opposite. So we have the opposite of 4 is -4. And then we add 7. So we have -4 plus 7, which gives you 3. Therefore, we can say that g of -3 is equal to 3. Now let's double check our work by using method 2, also known as the substitution method. So method 2 requires us to substitute in the value of -3 for any x we see into the original function. So let's copy down the original function. The original function is f of x, or in this case g of x, I should say. In this case, we're going to use just g of x to be consistent. So we have g of x is equal to, well, going back a little, it's the opposite of the absolute value of x minus 1 plus 7. And what we're going to do is to substitute in -3 for any x that we see in there. So we have g of -3 is equal to the opposite of the absolute value of -3 minus 1 plus 7. Now recall that the absolute value is a grouping symbol, so we need to evaluate what's inside first, just as we would do with the parentheses. So we have g of -3 is equal to the opposite of absolute value of -3 minus 1 is -4, and then plus 7. Here, we're going to, once again, evaluate what's inside of the absolute value symbols. So we have g of -3 is equal to the opposite of absolute value of -4, which happens to be 4, plus 7. And -4 plus 7 gives you 3. Therefore, once again, we have that g of -3 is equal to 3, which is consistent with our previously established result. Now, as part of an extension, we can say that we have the point with coordinates -3, 3. Why is that the case? Well, that's the case because our input, or x value, happens to be -3, and our output, or y value, happens to be 3. So this concludes this particular video on function notation, absolute value functions, part 4. Thank you for watching, and have a wonderful day.